All right, hello and welcome to this technical domain session as a part of the buildingSMART International Standards Summit, Schleusner 2023. Thank you for joining. My name is Jeffrey Ouellette. I will be your moderator today. Today's session, or this current session, is entitled IFC Forex Conversion Prototypes. And the discussion is being led by Greg Schleusner from the Technical Domain Steering Committee. The session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. We're seeing like 24 to 48 hours. Before I hand it over to Greg, I would like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of the session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For those of you here in the room, as usual, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, raise your hand. We have a mic. I'll run around and hand it off and exchange it. And a more formal matter here, I would like to bring to your attention that buildingSMART is committed to ensuring that participation in developing the standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. So please take a note of our antitrust code of conduct, either through the QR link or you can always find it on the buildingSMART.org website. So now I'd like to hand it over to Greg. And Greg, as part of this presentation, he'll also be working on that the manual whiteboard over here. So hopefully I'll try to dial in the camera a little bit and I'll see that all on screen.
And I'll try to make sure the mic is close enough too. So, okay, thanks everybody. So yesterday we went through a ton of slides. And we can go through a lot more, but I didn't feel like making another presentation. Kidding. But what seemed to make sense is having a closer to something that's a working session that actually gets engagement from the room to talk about taking something that looks like IFC today or is IFC today and actually walking through the process of how we might go about converting an existing instance file and how that might map to what we're actually talking about. So there's two potential forward steps we have here. There's we have IFC 4.3 or 4.1. It's probably 4.0 is probably what we have on the building side of things right now. I'll show. There's an intermediate step, which is to say what is a transition but not fully aligned and cleaned up and modernized version of IFC data today in a componentized system. So basically just this idea of taking objects and breaking them into pieces that relate back to an element. Externalizing some of the things because we're going to have to start that process earlier, but we could say that actually the things inside the components like the geometry could be exactly like they are in the step sort of SDF file today. Plus we have other representations. So what we're going to do is just take a file. I'm going to show you something. I'm going to ask for people to guess what's in there. Only a few of you will be able to guess like the relations, the hidden part, these sort of things, but these are the parts we have to work through too. And we'll go from there. And clearly I've looked at this, so I know the answers that I have mostly written down. So it's not like if you don't know the answers, we can't go anywhere. But the point is to make this sort of interactive session. Questions? This is the file. It just happens to be a very repeating thing. Very simple. We can walk through. I can show you what's in there. It doesn't have any. I don't think it has any groups. It is a building that's got IFC stories. It's got walls, doors, columns. Let me see what else is in here. Just check. A space. It's probably only one space. Shading device. I didn't know I put one in here. I am actually using a floor slab as a shading device. It's got openings. It's pretty simple. Doesn't have any complex like groupings or other things like that. So what we're going to do, like I said, is we're going to start to take this as a file on disk and start to break it into pieces. Think about what we actually have to plan for to sort of take the objects from the file, break them into pieces, and take the file itself and actually relate that back to the objects. Anyone want to venture a guess of where we probably need to start? Okay, well, these are all important things. So we'll do it the the basics, and then we'll talk about the actual the relationships that are actually in the files later. So first thing we have is spatial. Okay, so that's sort of a hidden concept in this world. So what else do we have in if you're a software developer and you're reading through the file, what else do we have to grab out of this file? So just to make sure I don't lose this, the structural part, what are we talking about here? Okay. So I made a very simple file. There's no reinforcement in this. Geometry. So elements. What do we if we're how do I ask this question? Does product mean anything, or is it actually just the elements that represent the products? I don't actually know the answer. I have an opinion though. Let's say it this way: the things that show up on the list, most people wouldn't know that those are products. They would just think of them as elements, right?
Yes.
Right. So, should we call those the elements themselves?
Or are we talking about the classification itself? How we classify each element?
Well,
Product is IFC product, right? Which is somewhere in the middle of a hierarchy.
yeah. So the way the definition of IFC is, you got a root, and the bottom is element and element type, and in between there's product and stuff all the way up. In the back. Okay. No systems in here, but it's okay. Yeah, so there's actually two things you're talking about there that actually show up in this file. The circulation part that's an abstract overlay, right? We don't really have a way to describe that, but certainly the voids / openings are there. Jesus. Yeah. So this is a kind of relationship, right? Anybody? Let's not start to name these things because they're not necessarily all that intuitive. Decompose.
You've got a online one.
Oh, there we go. There we go.
Quantities.
Okay. So we have units, and then we have properties. Okay. Anybody know why quantities are separate from properties and are not just kinds of properties? Anybody have a good reason?
It's complicated, but yeah, there's derived quantities and then there's stated quantities.
Extra letter in there. Anybody else?
Material layers, is that the same as material?
Composition.
Yeah.
Maybe we can slash the materials.
There are materials on here, but none of these are complex layered materials. So compositions.
You have project information, actors.
So you can have all these things, but remember, this is a very simple file. The things we're missing that are actually in the file before I say any of these things.
The simple file is maybe not relevant, but positioning and coordinate transformation, georeferencing.
Not there, but these are good things. But the coordinate, doesn't have any coordinate reference. But it certainly has positioning of some sort. Because this, no matter what, we have to consider position.
Owner history.
Nobody populates owner history. So it is there, but there's no values in it. Well, there's one value at the file level, probably. This came out of Revit, so I think there's one. Yeah.
Maybe in the future too.
Yeah, maybe two. Okay, so the basic stuff we're glossing over. There's a project, there's a site, right? And there's a building.
I hope you have a custom name for the project.
Do not.
It is actually populated.
We can look.
So I would look at that and classify it as a difference between the spatial structure and the logical structure.
I love how people
Project, site, building is.
people have names for things. People have names for things that are arbitrary. Anything else? I mean, this is a very simple building. What's that? Yeah, properties, quantities. Somebody mentioned relationships. There's a lot of relationships. Most relationships don't materialize in front of people in a named manner. Anything else? Okay, good one. Yeah, this is a very basic file, but there's a lot of typical stuff, so types are there. No annotations, but does any, well, okay. What's the official stance on annotations? Some tools can export them. Can anybody display them? Okay.
And we use that for survey data, that is very important for
Okay. We can assume they're there. They're not there, but we have to. So annotations. The only one I can think of that's there, that is not obvious, you're not seeing it anyway.
Hold on, let's switch it over.
It is visible.
I think there's a grid.
There you go. That's the only one that it was. Yeah, there is a grid.
You can see it better before. I know that.
Yeah, you're going through the.
Oh, I see.
Anybody else want to have me poke around, see if there's anything else in here that we're not covering? Yeah. It's a pretty basic file. I mean, at the end of the day. Anything else? Yeah, not populated. No assemblies, no groups, nothing like that. But we can pretend we have a group. But yeah.
We have also representation layers.
This one doesn't, but that's something to think about. The representation layers. Yep. Well, it was on the last one. We do have some types.
Alternate geometry representation. I thought this probably wouldn't have any, but there are walls in there. They might have ICs, right?
Online, they've added project data. I think we covered that already. Jesus.
Okay. So this is, I think this covers most plus, all plus a few others that don't exist in this file that we have to start to think about. So we have spatial, and then I added tacked on relationships because there's some non-spatial, there's certainly a lot of non-spatial relationships here. Materials, geometry, alternate geometry, whatever this language is. It says elements, voids and openings, units, properties, quantities, types, compositions, position, project site building. They would be that fall in the properties sort of thing. Well, we have to get there. we have to get to referencing things, but it's not the sort of the bread and butter of maybe where we'd start. Annotations, grids, and alternate geometry. Okay. Did I write down header? We don't have header. Header is like not a logical thing, but we actually need to know that what this if we're converting an existing file, we need to grab the header.
Yeah, it's more like file data.
Well, but this is a, if we missed it, we'd be screwed, right? If anybody use these things often, this is a good argument.
I aim to soon.
I'll put an asterisk by that. Yeah. So there's some metadata about the file itself that follows the, is it the express standard? Or, yeah, the express standard of how to make a file. Okay, so let's imagine we had to. Sorry, Jeff.
Yeah, I got it.
To want to arrive at this endpoint, what I have at my disposal are entities and components, and this maps very well to objects, if you think about them that way, or entities. But this is intentionally pretty open framework, so we can do a lot of things. So like a header can be an entity in this sort of very simple way of handling it. So let's talk about how we might take the basics of the file and break it apart. And feel free, anyone wants to suggest how we do this, because this I've mapped this out. The one thing I'll just show you, I can't for some reason switch between these that way. Come on. What kind of stupid thing is this? These are at least the relationships we haven't discussed that are in there that we'll get to at the bottom there. I don't know if you can read them all. If you can't, it's IFC relationship fills element, IFC void element, defines type, contains. Jesus, these things are impossible to read without under a camel case. Thank you, Jeff. Contains aggregates and associates material. So those are the stuff that, this is the plumbing that people point to as being useful that most people never see, like this component of this, which is actually something that I think one of the discussions about looking at IFC in the future is, well, this is something that we should extend because the relationships themselves are quite powerful. But if they're the most hidden part of IFC, then they're the least understood. And then there's the sort of things that have typicals and that things that have unique, but we don't need to go from there. Unfortunately, with the, yeah, I can do like that.
Quick question. Under typical, you had the header. Is that typical data?
Oh, I think I just threw this in there and then I put typical after the fact.
Okay.
Yeah. Well, I had typical. Yeah. Well, it is typical to a file. This is true. It's units that falls in that category as well. Okay, so let's start there. So the way we think about the system is you have an element and you have a component, and like the first time you make an element, you use the component to make it. So the basic structure is, we talked about this yesterday if you weren't here, but you have a entity ID, and that's the shared concept. If we talk about the header, we would not have much shared. We just have one thing that describes a header. So the first thing I would have is a header component. This is a function, if we want to capture everything that's in one of these files, we have to capture it. This is sort of basics. Now, how this gets captured, we would decide if we want to, do any conversion. If we would basically just take the text of the header and somehow encapsulate it in its own file, shove it into attached inside a JSON sort of sub quote. All of these are options, but let's assume we do that. Does everybody know what a header looks like in a file like this? Oh, it's got data in it. Anybody not know? Okay, so this is meant to be interactive because this is explanatory. If all I had to do was, what's going on? I don't understand Max. Oh shoot, I've never thought of opening a text file on a Mac. I have Visual Studio on here, so if that will work.
Text app. Text app works.
Almost there. Okay, there we go. So, sorry, I don't know how. Anybody have any clue how to zoom in Visual Studio? Is it like the shift? Command shift. Control shift. Oh God.
Your right hand side. So there is that gear button.
No, button. It is button. There you go. See the header? Yeah.
Yes, click there.
Setting.
Search for font size. At the top, font size. It's there. Font size button. Down there. Can you increase that 18 or something like that? You have it at the top as a new tab. There.
Yep. Okay, this is always an adventure. Okay, so when we're talking about Jesus, we're talking about a header. This is what we're talking about, and this is like the code words of Building Smart, right? This is an express encoded file that uses a step representation, and the proper way to represent express data is to have a header and then a data section. I think I got that all right. I learned this as I go. So when we're talking about the header, that's basically like everything about this file being published at a certain time by a certain toolkit version of the file. But it's, if you were to look in the info panel, when clicking on this thing in any of these tools or the file panel, most of this information is coming from there. Okay? So it's important to capture. So especially if we're going to be converting from an existing file to this component approach. Okay, so we have the header. Next thing we get in this particular order, and order is not consistent. It's not actually intended to be, but so what you have is the sort of large chunk of units. And this is the placement, I think, right?
Those are used for placement.
Yeah.
So those are common vectors. Origin points, x-axis level.
Yeah, so this is placement, and then we have a section of units. This is an interesting discussion about the way IFC works today. Is these are sort of, basically we have some like IFC SI unit. We have, like the frequency unit is hertz, right? The time unit is seconds. So all of these are in here by default. And so if we have these, I think we need to put a pin in this one because we might address these separately. So let's talk about the simplest thing, which is the actual elements themselves. This is the sort of most understandable concept, which is, looking at this list. I have one column type. I made this easy on myself. So it's all the same. So let's start there. So I'm not going to draw the entities all the time. So for every column in this file, let's start to break them apart. What does every column have about itself? Anybody have it? Take a guess in the back. What's that? Nope. Columns don't have levels. This is how IFC works. Then this is why it's important to stretch it apart. This is a relationship to a story. A column has that. So let's say call geometry. Okay. We certainly have one bit of geometry for every column. Okay. Do we think that's true in this one? That's how these extruded columns will have two? Let's say it does.
Very common.
Yeah, it could. For the simple one.
So what we should be doing is thinking that I've just defined by instantiating this thing in a new component. I've said I've defined the column entity, and now I'm defining new components that describe that column. Okay, so I might have two of those. Then what was said is I should draw the boxes first. Properties. So let's talk about attributes. What do you mean by an attribute? Property, right?
Well, so an attribute is the one that shows up on the line. Right, IFC column, parentheses, everything after that is an attribute. A property would be well defined by property set.
Jesus.
Property
Okay.
Set, blah, blah, blah.
So
Attributes are always a part of the element or entity or whatever, and properties are optional.
are they is there a reason to distinguish here? Yes or no?
Attributes are inherent to the description of the object.
Okay, so this is the class definition, and inheritance assumes I have name.
I don't want to. This is another 2-hour discussion.
Yeah.
But if we're taking away the concept of IFC column, right, and we're talking about elements that can be tagged
As a column,
then
everything's a
attributes
properties.
kind of go away,
Yeah.
right? I mean, as special.
He was asking, what does it mean now?
Yeah.
What it means now is those attributes are always inherent to the description of the object. The properties are always optional.
And the reason you can hook a property to a column is because the column has some sort of attribute that would hook into a relationship that would hook into a property.
Okay, so in this world, in this conversion, we understand they're different, but are they should we make a meaningful distinction when making a conversion to say, well, one's the inherent property or the inherent information, and the other is just other stuff I want to have on this? Is there a difference between these things? I mean, yes, we have two names for them. It's one of these things when we're talking about simplification, why does it matter where these things come from that we give them a different name, right? The definition of why, a column, giving it, it's something different than a property. So anybody have a strong opinion that they have to be separate? In the back.
That would help if we want to use that as a part of semantics, because that's those attributes. And one, entity would be just a tag, but the main description would not have any consequences. So I would say maybe we can have a component for all those attributes, and the rest could be per definition. So maybe they're not there. Maybe we can have them as a new component.
Okay, so if we're actually doing a conversion, I'm pushing for you guys to make decisions, but we can come up, but it might make perfect sense to say all the common attributes actually are their own component.
So that the suggestion I would make for discussion, right, is we could consider them a property set.
Right.
Well, the previous attributes that would always exist.
Right.
And would have some name like ID, whatever.
Right.
Attributes, whatever you want to call it. So that would be
The attributes property set.
yeah, right, whatever you want to
Right.
call it. So that would be a possibility, but I don't know.
Wait, so basically, we agree we should capture them. It's maybe not inherent, and we should be able to identify them. So we shouldn't have a single component with all properties and attributes, so you can't figure out which is which. But clearly, it makes sense to include them, and if we're going to store properties, they're just another kind of property in this case.
So to that example that you were just carrying, the column inherits from building element, but does not have any attributes in this very case. Whereas, for instance, the window has 2 extra attributes.
Right.
It has overall height and overall width. Just to
Yeah.
length.
So you have it open. What do we have on column that came from above?
Everything that is in common with building element. No extra attributes. It's just like we were discussing today. It's a classification, but it doesn't carry any extra semantic attribute that comes with that classification.
Right, so I think that the interesting question here, right, is for this ID data. Is there one ID data which would be different for a window and a column? Or do we really want to maintain a hierarchy where the column uses the building data, ID data, and window has on top of that a different component, which is the window ID data? No comment on that at the moment. But probably, I'd say let's collapse that, just have the ID data. But it could go either way with it.
Okay, so we have actually, we brought this up yesterday. Like maybe we need that ID component because these are what these things are for right now, right? So maybe we put the
ID.
and this thing is the first thing we've sort of introduced that's not IFC traditionally, because basically we're saying we're putting this into a system that can put any other data into it. So you start to think, well, I need a common thing that GIS data would also have, and this could not necessarily have the same data, but I know it's the place I look for identification across these different data sets.
Yeah, and I think the other confusion is that because of the way that that step is configured, and Claudio sort of was pointing to that, is there are some of that descriptive or ID information that occurs at those higher abstract levels, right? So yes, there's things that are in IFC product, there's things that are in IFC element, and there's things that are a part of its specific element definition. But the lower the level in the hierarchy doesn't duplicate anything that's in the above level hierarchies, right? So each level, abstract level, has its own.
There are some places that you disclude them, which is crazy, but
Yeah, and then you can have overrides too, for instance.
Yeah. Okay. So one of the discussion. Go ahead, Claudia.
Just add another little bit of thing. Some of these attributes are optional. So I discussed this idea of the window, and it had, we said, predefined type. No, sorry, it had, here, overall height and overall width, which are two positive rational, positive length measures, but they are optional. And so we could say, let's put them aside in an attribute set that can become a property set if you want. And you don't have to have it. So it could be a component that is either populated or not populated. But there are other scenarios in IFC at the moment where we actually have mandatory attributes like that. So for instance, IFC pile, which also inherits from building elements, so it's just a sibling of the column and the window, it has a non-optional, so a compulsory IFC pile type enum. So we said at some point, in in order to be a pile, you have to have this extra.
Yep.
So that is where the things become a little bit complicated, because you'll have to have a mandatory extra element to say, yeah, you do qualify to belong to that
So
class.
before he gets there, is an enum just a classification?
Yeah.
Okay.
Right. So that particular one is this interesting special case, right? Because, well, in the case that if we're talking about having an element, right, that is no longer IFC wall, IFC window, IFC pipe.
Wait, like the definition is not inherent to these things. Yeah.
Right. Then that is part of the categorization of the object. So that we need to talk about what component would contain the fact that it's a pipe of a particular pipe enum. And that would go away from the ID
Right.
component, presumably, or maybe not. Or
Well-
the categorization is in there.
Well, do we want to enable people to make new kinds of enumerations that we didn't come across? I think the answer is yes.
Yeah.
Yeah.
It's been a long argument.
Right. Okay. So I think we're talking about the right things. So we have on this column, we have geometry. We have two kinds. We have properties. We're going to have this ID component. So what have we got so far? We know what it geometrically looks like. We can describe it. We have not written down property sets. That's going to be quantities. I didn't have quantities.
Yeah, quantities, and then material.
Sorry, could you just clarify? Are we talking about extracting information from the current IFC, or like making a new IFC?
No, we're doing the middle step, which is taking an existing IFC. Let's say we have to migrate to this new standard. What's the forward migration path look for a current IFC file? So we're not necessarily solving everything we would like to solve right now, but I have IFCs are currently structured in a certain way. I'm putting it in this component approach. What are the decisions we need to think about as we move it forward? And then there's a whole slightly what if I have what are the things I would make greenfield that no existing data is coming? How would I make anything different? These are the
Part of that would be this idea of type. Is it a unique thing, or is it a thing that is other instances inherent from?
well. So let's look at this. Can you show my screen? So what we showed, I think actually I'm smarter than I thought. What I showed yesterday was actually using columns. Here. Oh, it shows white. So the bottom, my example was actually trying to walk through things. The only thing we should ignore is the name of my relationship, because this is not, as Thomas pointed out, the proper name of this relationship in IFC today. But what you see on the left is, so Jeff just said materials, and I haven't written it down yet because technically they're related. But I'm indicating that what people often do is just call something a material as a property. It's easy, right? So that's the dumb way of showing it on those entities on the left and the bottom. And then I'm showing the geometry. Most of it I'm showing the columns. I'm not really showing much of the left because, or excuse me, the implication here is like the columns are quite typical. So they share geometry, and that's why they're on the left. But the blue boxes on the right are the lower. The slabs will vary more often because they have different openings. I'm making this up. It's explanatory data, not real. But that I have a relationship that links type across these things. And actually what we do today, we just have many names for this concept. And then the geometry, the sort of unique geometry is on the right of this scenario. So what we're actually describing on the board here in a lot of cases, this column is 100% typical everywhere right now. I didn't number them. I didn't do anything. So actually what we're describing is the type. Well, not in IFC context. We're describing a map plus we're describing a type. I think. Is that it?
Localization make them instance is not type.
Well, so let's actually talk through this because this is where it gets sort of
Yeah, and instance geometry is a transformation on type geometry.
so. But the method by which we transform instance geometry from type geometry is a map, right?
IFC mapped item.
Right. Is there more than one way to do this?
Oh, of course there is, but no, IFC mapped item is the main.
Yeah. So this is where this slide set came out of is the properties. We use the word type, and actually people use this colloquially. Use it in passing, but actually in IFC, type means properties that are shared, not geometry, right? So this is where you get this concept of map, which is I have to do both if they share geometry and properties. And it gets grosser if you start to put these together. And so this is why there's a big opportunity to touch on this. So what we're looking at over here, let's say this is all I need. 2 geometries. There could be more than one property component. Property sets could be there each component. I have an ID and quantities. And really what we're saying is this is E1, let's call that element 1, E2, or E2 through, I don't know, I think there's like let's say there's 100 columns. 101 is over here. And actually, if they're 100% the same, I'm making a one to many relationship with 100 other entities, right? The unique. Go ahead.
I was thinking, is the E1 is that also an instance or is that a type?
Well, in the context of this, they're equivalent.
I was just thinking about the transformation because typically you won't have, if you have like a type geometry, then that is like say in origin, it doesn't have transformation. But then if you had this kind of that, the others, you have like an instance and then you have 100 instances more that are identical except the location, then you might have strange transformations there.
Yeah, so certainly the yellows are what we're calling the locations in this sort of example. So that is something each one of these has, right? Should we be always calling this a transformation? No matter what? Just to be simplified at the time?
Probably we should always call it a location, which happens to have a
Transformation. Okay. So,
or position, whatever.
okay, so let's come back to this relationship because what the one thing we need on all 100 of these is a location.
Well, so I would say for the geometry, I don't think it's take the geometry, right? To your point, I think E2, 3, 1, and 1 also have geometry. It's just that their geometry is position, pointer to type geometry.
Okay, so we would, so this is a nuanced modeling thing that we've not done, so it's a good thing to talk through. So let's draw the entity. And I'm going to keep them on the right side, so 2 through 100 and 1. Okay? And we're saying we have geom We have a geom component on the what we're assuming is the typical.
Yeah.
So there's a couple ways to handle this. We can have a relationship from this component to the entity, but what you're suggesting is actually we're going to have another component on the 100 that's geometry. And what is that?
In its geometry, going into detail, would have two attributes. One is position.
Well, no, what I'm asking is this, am I making a component to component relationship?
Yes.
And are we hurting ourselves or helping ourselves by calling this something typical? Or like right now we would call this a map, right?
Yeah, right. So if you said I'm copying it over, like if you didn't have that geo on the left, right?
Right.
Then you'd have to have some intelligence. When I said, give me the geometry of E15.
Right.
You'd have to have some intelligence that says, okay, look for the geometry. Oh, it's tied to E1. Also look for my position component.
Right.
And now do some magic.
Right.
Right. The way I was just suggesting, if you said, give me the geometry for E15, you get the geometry component. And that contains the pointer and the position, because the two are, you wouldn't want them separate, I guess.
Okay, so we're saying that, and this is does every piece of geometry in IFC today actually do this exactly the way you're describing?
Every mapped item.
Every mapped item does. So it actually has a piece of geometry, but then it just points to the other one.
Yeah.
Okay.
IFC mapped item is the geometric representation item.
That is super confusing, but it makes sense. Okay, that's why you want to describe it. So basically, for convenience, we assume anything that's an element has geometry. If I inquire about it, it's going to tell me where to go.
We don't have to do that.
Is this the right way to solve it? Because that puts the relationship inside the component versus outside the component. Posse.
So, yeah, I'm thinking like if is the geometry, if you think about the geometry on the right, is that kind of independent of the E1? So we could we directly just refer to the same geometry in multiple, because geometry is a component as such.
Yep.
So if we, instead of like thinking that we need to map, we could just refer to the same geometry instead of using the mapping. So, and then in addition, we do have the transformation. So if the geometry is just represents the shape, doesn't have any location or transformation information, then we can have the geometries kind of standalone, and we can refer from several entities to the same geometry without any mapped geometry.
You still need a separate position.
Sure, yeah, but position is a different component.
Look, yeah.
So okay, what if I have two mapped representations?
Forget mapped. You are just referring to the same
Yeah.
component geometry.
No, so imagine that, okay, we have a cube, right?
Yeah.
And we have a bunch of cubes all over the place.
Yes.
So what you're saying makes perfect sense. Every instance would have a position, and it would say, I'm using this cube.
Yes.
Great. Now let's have a cube and a sphere. That's
Yeah.
two separate geometries.
Yes.
And they have two different relative positions. So the cube is at the origin, the sphere
The
is,
cube doesn't have any position.
it does for the instance.
Well, so
Sure, yeah. It does for the instance, but as such, the cube is, let's say, it's represented just by three numbers.
No, right. So let's say the cube and the sphere, the type, the conceptual are at the origin.
Yeah.
Right. So, and that's just because you need numbers to represent these things.
Yeah.
Now I have an instance of it. Right? I have an instance that has a cube and a sphere in space. Right. So I'm going to point to that geometry of the cube, and I'm going to point to the geometry of the sphere, and say, okay, this is my geometry, but now I have to position this.
Yeah.
But what if the positioning is different for the two?
well, okay. So let's think about this. So let's say let's cross out this geometry for now. And actually sharing for multiple entities makes perfect sense, right? I can get some traits from, I'm using traits the most generic thing. I get some geometry traits from one typical thing and some properties from another, just fine. Let's say I have E1 and E101, and that's your cube and your sphere. Let's just say. So what if I, on each one of these, had location, and instead I'm actually just making a relationship
Yes.
here
Yes.
and a relationship here.
Then I think we're saying the same thing.
Well, there's inherently no geometry on these things. It just is a complete reference by relationship.
If that ever happened, we will use a different locations relative to the shared geometry. I would consider E1 is completely one independent unit, include two pieces of geometry. And then E2 is completely and relocate or give a position for E1.
Yeah.
If by any chance any piece of things I want to override, then I just have an override kind of a component. I say, okay, this piece of geometry I will override with different location. Then the others I don't even mention. That means I reuse everything from them. Why you specify two pieces of geometry and say each have a different location?
Maybe it's very take another paper and like just that. Okay.
This is why we're doing this interactively. You can hold the markers too.
Yeah, I may have even worse handwriting than you.
That's a compliment.
Okay, so we have the cube, and then we have a sphere. These are like just independent geometrical definitions, and then we have the E1.
Just to clarify, can we call them elements then? Are they separate elements from?
Yeah, I don't know about the terminology.
Yeah, they would. I mean, nothing can really exist as a component without being part of an element.
Yeah. So one of the complications here is that one of the horrible things IFC does is you can have mapped geometry to just geometry that's sitting in the universe, right? It doesn't actually have to be associated to an entity at all.
Yeah.
Which is horrible. But so let's pin that for now. Yeah. So I guess probably it's irrelevant if they're part of an entity or not at the moment.
We would assign them an entity.
Yeah.
Great.
So this would be kind of geometry entities.
Yeah, it'd be like give it a
elements.
generic. There'd be elements that have components, and they're like reuse geometry or some generic. That's how you should think about them.
Okay.
To your point, let's call it E2 and E3 then.
Yeah.
Okay. Call the cube E2 and the sphere E3.
Ah, okay. So this is like, okay. Let's see. We have E2, and then this is E3 and E4.
Right.
Okay. And then so this one would have then location 1. If this would have refer to both cube and sphere, then this would have location 2, and so this would refer to this, and this would refer to that, and
The location component refers to
So this is the way we've talked about this, because we would externalize it as actual relationships. The location wouldn't directly.
okay. So there would be a relation then.
Yep.
Yeah. That's fine. Yeah.
Yeah. But it basically says to your sort of line of questioning. Well, okay, so let's talk about the questions we're trying to talk through here. Map goes away in this scenario, right?
Mm-hmm. Yeah.
So most of the implementation details here are convenience after this point, right? Because this is very possible. You have a relationship between a location and a piece of geometry, and you can have a one-to-many. It's just a question of how you interrogate the data.
Right. It's a question I want to ask. The most common question that will ever be asked. Well, the most common question they're asked is, give me your properties. But the second most common question they'll be asked is, what do you look like?
Right.
Give me your geometry.
Right.
So how do I answer E1, give me your geometry from this setup?
Right. So there's the long way is to iterate through all the entities of the thing you care, kind of things you care about, all things that are called column. Find all their locations, and then find the relationships that touch the location of those entities, and then find the other side, which is all the other entities on the other side of those relationships. It's the long way.
Yeah.
The shorter way is if the relationship told you what it did.
Yeah, it could be like a ternary relationship. It could have like the element transformation and the pointer to this.
Right. And if you said provides location,
Consider a relationship like a separate component.
Yep. Yeah, so you could have a
No, it's okay. It's the only way. In that case, we can have a special relationship representation of object.
provides geometry or provides representation or
Because you put on the okay, now it's
yeah.
So really, these are two components, right? R1 and R2. And R1 contains a pointer to lock 1 and a pointer to E3. And R2 contains a pointer to lock 2 and a pointer to E4.
Right.
And I guess what I had originally suggested is have R1 and R2 actually be part of E1. Right? Have this actually be
a part
geometry
of
component.
right. So the reason to separate these out is that the implication is that I should be able to share something without having to share the geometry. Right. And so if and I actually don't think that what you're describing, because if I have geometry, I don't have to share it.
Yeah.
Right. But if I have trying to think of the place this it basically just makes duplicate data. That's all it does. Because I still have to have the relationship.
Yeah.
And I'm adding a component. It's just a question of, like, it would make a lot of sense if we had dumb or non-descriptive relationships, right? If we went down a path of, I only want 10 relationships total. And so a map, like, or if we want more descriptive relationships, which is to say that actually, Sergey was saying, this actually provides representation or provides geometry, whatever the right way of thinking about it is.
I think there are some relations that we need to define that are kind of fundamental to the whole thing.
Right.
And then there are kind of more kind of free relations that we can then just enumerate that in the kind of not in the schema but kind of associated data that these are the list of relation types that IFC supports.
Yeah, absolutely. Because one of the things that you could imagine a simplification of this one, because right now, this example, this is like what we're describing almost would have a relationship, potentially have a relationship type for every one of these, versus an entity relationship that says typed or something like this. And you get like all my this entity provides all these entities, and they're duplicate across the board.
So one more thing to keep in mind, right? So I think both in IFC and I think generically, there is a concept of the position of the object, right? What that position means, of course, is arbitrary. But it's some point in the world that we anchor this object to.
So even though I'm showing a typical, it would have a location itself.
Right. And so it is a little confusing because that probably if you had the location 1 and location 2 associated with geometry, you'd still need a location 0, right? Which is the universal location of the thing. And that would be what you'd ask for if you said, give me the location for this object.
Well, can this thing not have a location? Absolutely. I mean, realistically, it's not instantiated anywhere.
Yeah, I was thinking the same. Like this would be, I think like a prototype.
Well, so the type wouldn't, right? But the instance.
Yeah, instances, sure. But I think where we started this discussion was that the E1 is that an instance or is it?
It's a prototype.
It's
that's no
a
location.
prototype. Then it would
Okay.
location.
Yeah.
Yeah, and it wouldn't show anywhere.
Right.
It's not representing anything that will be built. Then the instances are the actual.
And indeed, the location is optional. Even, I could have a conceptual knowledge that I have 100 chairs in this room. I don't know, I don't need to know that they are in a specific geometric space other than belonging to this room.
Right.
So, like a transformation matrix is not necessarily that we have the semantic that they're here, but not where they are.
Well, and realistically, one of the scenarios you could imagine is
And I'm making this point to make clear that we might not even have the geometry for this object. Because
Sure.
people might want to have it,
Right.
but we might not have it. Because
sorry.
Actually, rather confusingly, and I see product as an optional placement. So right, without that placement, then I mean, I guess it's assumed to be identity at that point, as opposed to being invisible.
You can focus on this quickly because we are going from a object-oriented approach with a lot of classifications
Yep.
to a component system or a container of different components of information.
Yep.
But do we have any rules for this? Because as a building owner,
Not yet.
I like to do the development of this, but as a building owner that's going to maintain this after the project is finished for 20, 50 or whatever time frames.
No.
Kind of scary.
No. I mean, this is why we're having this conversation. This is not setting rules, because what is also true is, like, we have a ton of concepts that, like I said, like all of these do a little bit of what we're talking about here. So type does something.
To your
Oh.
point, though, right? A separate discussion, which is the one we were just in an hour ago, right? Is forget IC5, right? Forget this. IFC, you say about as an IFC 2x3. There's no guarantee that 50 years from now, any software on the planet is going to read an IFC 2x3 file.
But you still need software.
It's a text file. Some humans can read it, presuming that we still have humans.
Yeah.
They can read
And
it.
just to look at an example I'm doing today, I'm actually taking the header file and actually extract that information and put it in my own Excel sheets to have a summary of all the IFC files I have in the contract.
Yep.
And see if they are actually filled out. and I also wanted to do more of like mapping up general data. How much proxy elements are there in the contents of all the files? How many of these different element types? To have more general understanding of the files of the project. And then I can go down to each file and do more like a one-to-one conversation with the advisor or the constructor. Constructor part. But like this is like really difficult for me to say I'm going to be the owner of this for the future. How do I
No, just
I have no rules, no like
no. So
what way, and I have different projects, and they are doing this in different ways.
No, so the point of all this is we have to figure out what we're going to do for the future, and then we have to figure out how to convert. And what we can't do is, can we go back to the slides, Jeff? He's taking a nap. Don't worry about it. If I wasn't standing up, I would be sleeping. We can't reproduce this because it's non-useful. Because by the time you get here, no one is implemented. And like inventory is a perfect example of a group of things that have no placement, right? Like this is like that's what it's for. But like all these things exist, and we've made them all independently, but you can't use them together because like even if you look at the sort of use cases like the IFC referent to a linear element is not available to building elements. It's like this sort of stuff. So you are 100% correct. This is us figuring out what are the things we have to nail down in rules as we move forward. It's not you can do anything you want.
No, I mean, right. The whole point is
But I have to just say, because it was hybrid, if I want to choose one thing, is it what the way that different project is consistent with each other.
Yeah. So we have to be very like just concrete about this is how this one way you make this relationship. Now, and this is us walking through it. What are the pros and cons of different ones? Not you can do all of them. Yeah.
So the point is that at some point, the protocol will tell you, okay, given this data scenario, this is the snapshot today. This is how the data looks today in its entirety. Am I wrong? Yes.
No.
That's the point of the protocol, right? It's going to give you so that if an element or component was changed 3-4 times over the past 3 years, you can still say, okay, but today how does it look? But that's the timestamp hashed, perhaps.
Yeah.
Timestamp certified version of AI.
I think you in this you should think more that the BIM is in a database, and then because now if you think about IFC 5, it's kind of static, fixed times, like a snapshot of the theme. But this is more dynamic. So I think in facility management, this would be give more opportunities because then you can actually add more information and maintain it more easily because it's not like one fixed world.
Yeah. So this is a perfect example where I know people do this in the asset space. They wouldn't do it with a column, but people do this with like equipment all the time, where the actual equipment changes, but the thing they called that piece of equipment is the same, right? So like pump, and then you swap out the model, right? But so in this scenario, like if we're talking about, well, the geometry for that pump has changed, the manufacturer for that pump's changed, but actually that placement of that pump is the same pump, right? So you don't want to modify that one. So this is why we're leaning on the relationship concept to say that actually I don't have to change that. I just change the thing it points to. And now because I have time on each one of those components, I can update my data over time.
Yeah, I think for the design, like like this, when information geometry is mutable and when it's not mutable. Like, yeah, in the projects, you have to have different typesets for it, like it's mutable and it's not mutable.
What we talked about thus far is more of a
Yeah, but that's also from compact perspective and also
Yep.
how to hand over and a lot of different human touch for this.
no. I mean, there's a
Because that's what make it easier because so many projects that IFC created is in flight into the last minute because people are changing it and they're not changing, they're deleting it and then you update it.
Yeah.
And instead of having a fixed number, it's brilliant.
Yeah. So the point on the mutability, immutability. I mean, the first time we wrote this down and first time we talked about it, we said everything's immutable. There are scenarios where people want to people own their own data and want to mutate it. that they don't want to keep everything around. So this is the place we were at in the discussion. Where are we at in time? 15 minutes. So we have not gone far, but we've actually talked about a lot. So let's just sort of recap a little bit. So the only thing we haven't shown for this column is how it starts to relate back to the other stuff that was in the file. So let's do this from scratch. Let's say each one of these instances of that column, let's use blue. We're going to figure out the relationship to the geometry, and we have sort of a couple paths that we can formalize on. Has a location, has a geometry, and those have a relationship to the geometry the location has. But the E2s, well, let's call it E2 through E100, they also have a bunch of other relationships, right? You mentioned material, you mentioned level, right? So we have the entity, let's call this 200 IFC story, and there's many of these, right? There's the building, there's the site. Sorry, this is, I'm drawing this wrong. 201, E202. So this is aggregates or spatial?
Spatial. Well-contained spatial.
Yeah. So these are all separate relationships. The logical thing to do, especially on this sort of thing, is if we're not trying to fix the concept, we just use the relationship name. So it's maps 100%. So
but it's two separate answers, right? 202 aggregates, 201 aggregates, 200.
right.
And 200 is well-contained spatial structure because that's obvious.
Okay. So this is This is a question. Do we make direct, or so like? Okay. So like this is I have this backwards, right?
The site aggregates the building.
Right.
The building aggregates the stories. And the stories.
So it is bottom up,
Yeah.
correct? Okay. So we're saying we have a aggregates relationship, right? And then we have another one.
Yeah. That's right. Yeah.
And then
And
we
then
do
have RCS, raw contained in spatial structure. So it's S feature.
to here.
And then to that.
Is this the right way to think about this?
Well, if we think that this top left box is like one instance.
Well, it's 100 instances.
Okay, put a bunch of little arrows.
Yeah.
There you go, yeah.
Okay. Does this make sense? So one of the big bits of feedback is spatial structure should not be inherited in the data. What this implies is this thing can't be positioned to the site. Well, it can be, but it's illogical from the building perspective to think of it that way.
Depends.
Well, I know it's possible, but is this non-explicit relationship problematic if we're simply saying, well, you should just make the explicit one? Like each one of these should actually just have 3 relationships apiece versus going to the spatial structure.
So you're not talking about position, you're talking about literal containment.
Yeah, containment.
I think we should actually have a list of discussion to design principles and what we want to achieve this, because if we're going to achieve to have control of a lot of information and a lot of instances, then that might be a design choice. If we want to have some data with a lot of information, it doesn't.
Well, the reason that these are good questions, the reason this comes up is the infrastructure people point out that this is not how they see the world. Even if they have columns in a building, they actually just want to think as being on the same site as a rail network that's right next to it, right?
But that's allowed in IFC.
I think it's a lot.
Right. But what does this give us that making this 3 relationships wouldn't.
Well, the thing is that if you have this kind of logical thing that these columns are in this story, and this story is in this building, and this building is in this side. So, yeah, that is kind of just logical.
Can a story be in multiple buildings? Well, in reality, can it?
I think you'll get into the story. There's another level in there. Those columns can all be in rooms,
Right.
right? And those rooms can be in stories, which can be in.
Right. So this is nothing about this is like, because of the system, we could also have, you could be in a room and you could be also in a, another site. None of this is contradictory. It's just whether, how many versions of these inheritance stories are multi-level inheritance. That's,
I think it depends on the user. Like you can have everything directly associated with the project. But I don't think you literally need any of these. I mean, some of the MVPs require several levels, but conceptually, you can say, I don't care about any of it. There's just a bunch of stuff in space, right?
Right.
But you might also care about, I want to see all the chairs in room 107.
right. But you could have a direct relationship to this, the column or chair to the space, right? Not that none of this is invalid. It's just whether these kind of like, this is a good idea in our world was only this. Do we do this in other spatial contexts? Sorry, one sec. Like,
I'm saying it's optional. We allow it.
right, but should we be more formal than allowing things?
I think it's good to have the flexibility of that. I think this can be simplified in terms, because we currently have a range of relationships that perhaps carry some semantic value with them, just like the column doesn't need to necessarily be different from a wall. We only classify it differently. The same applies to some relationships. We could have a general grouping relationship that we can then perhaps tag with a classification of sorts.
There's one argument made a while back saying, what if you just had IFC rel, and then the relationship was an enumeration?
Yeah.
And everything was just a rel, and then depending on what the enumeration said, determined what was happening.
And the value that you get is that, you still need to, I assume, allow for iterative grouping, so that if you could have a group of groups,
Okay.
which allow you to create multiple hierarchical structures, and then if you have that enumeration or what perhaps even open inside, then this allows us to create whatever level of flexibility or constraint that any specific business case would need. But I think in the long term, and to come to your point, all of this simplification of the structure will probably need to have some level of quality assurance added to that. So, but I think that what we said yesterday, that IDS sits within IFC5. It sits in 2 different ways. It can sit there as a component, but it can also sit there as any of these grouping rules. So it sits there as a level of quality assurance on the workflows that we want to enforce.
Sorry, in the back first. He's been.
Yeah, just taking one step back, let's look at this. It was coming to my mind, why are the components anything more than just a list of relationships? Don't simplify the thing, is the way I understand it. This also what we try to do with the concept of OTL inheritance. And then it gives us a graph, which is the reference, which is complex, we have the data.
Right, but you lose the ability to describe the same. You lose the ability to describe the same thing. Like versus, yes, you're describing.
You could still have relationships that you can work with, then you have flexible grouping. So you don't need to rely on one standard strict way of grouping, but you can group things differently. Of course, you need to validate.
Well, so actually, I mean, if you think about it, what is a component? A component actually just says, I'm a component, I have an ID, I have a version, and I have an entity, right? That's it.
But what I get now with the construction of our components is that it contains relationships.
No, it doesn't.
But also, okay.
No, the relationship. So this is a meaningful.
Then it would generate multiplication. Okay. Doesn't it?
No, so like if you look at this, like what you're seeing here is we've externalized all these relationships. They're not in the data. They are external to the components, and that's actually in IFC today, and actually that's what we'll extend. So they're not. The main thing we've discussed is they're not going to be. What's the word I'm looking? Inverse. So these things basically say this relationship identifies this direction and that direction. This doesn't know about the relationship intentionally because I need to be able to move this around and not share the relationship. And this doesn't know about the relationship.
So then why does the relationship have to be externalized? Why can't it just be a component?
What is? What is its own component?
Its own component.
I think we're mess up the relationship with the spatial positions. There are many kind of relationship and spatial collection or just a property relationship. However, if we discuss, if you want to visualize the things, every geometry piece has a position, and the position has a reference position. You don't define the local position. You define the position relative to another thing. But where do you relative them to? That's the relationship I think we want to be very clear. So this position is relative to the story, or you relative to the site, or you relative to this building. So I think we want to focus on one thing, not everything.
Well, no, I mean,
It's confused.
there is a lot here, but like to this point, like if we try to put a bow on this in the last 5 minutes, what have we talked about? We've talked about a column. Where does it get its geometric representation from? And then how does it relate back to some of these sort of spatial constructs? And if we tie this all back together, we have this thing you just talked about is local, this sort of the relative to what position, right? Which I actually have no idea what the answer is do we have a formal way of saying actually the site is referenced to this Cartesian system, or can these things?
The local placements are relative to each other.
Right.
Right, and then relative to an entity, an IT now, right? So the column local placement is relative to the level local placement, to the building local placement, to the slate local placement, but there's no enforcement of that because it's a different hierarchy.
Right.
So you could make the column local placement even with the containment you see there. You can make the column local placement relative to the site, relative to the building, relative to a room somewhere, right?
That needs to be defined.
Right, and that's a mess.
Right.
And I've seen that in file before, where the site contained the building, but the site's local placement was relative to the building's local placement. It's very messy.
So it's a recursive placement, which is semantically correct, and currently perhaps a little bit difficult to compute. Because there are a number of different forms of placement. But to come back to the point that you're trying to make again, I think in our infrastructure we need to keep that semantic richness,
Yes.
and the reference that you were saying, but make life easier for developers. So anytime that you export a geometry, you export whatever complex semantic you want, extrusions, holes and stuff, but also a GLTF. And whenever you export a relative placement, you export whatever semantic you want, alignment, non-alignment, and so on, but you also export the transformation matrix 4x4. And that allows people to get the data, put it on the screen, super easy. We lower the bar for many more people coming into the business with easy entry point to representation and coordination.
Yeah, it does beg the question if we should.
Sorry.
Yeah.
Since the last one said it makes super short. I would advise to have a time frame for both, like from the creation of the assets to the end of the asset and the end of the building or project. And what do you made in different areas because a lot of this is core concepts, of course, but a lot of this is really on the asset production and not how to handle it over time. And we have different approaches to how to do it. So I would advise you to make a timeline for what is the system.
It's one of the things I would point out is timelines are bad because people think in sequence. I can have a building before I have a site, right? Absolutely, and we should allow for this.
Yeah, but you have
No, I think the design goal in this context should be out of order, because this is a really important part of this discussion is out of order, right? So I should not have to have the site position before I have the building position because otherwise I can't place things that I know go on level 3, right? And so these are things we have to think through. So I think the design goal has to be what's
But now you're thinking on the design. Now you're thinking that workflow from a production or design perspective. Like, see,
well the production of this data, right? What's the big goals are we have to meet a criteria, we have to be distributed, we have to allow for people to make relationships of data they don't own, but it also implies that we need to support both the flexibility of, like, I want to have placement relative to something, or I want to have global placement. And what we need to do is be as hard and firm as possible on what those variations are and not allow the half measures to creep in without a real decision being made but the benefit of this approach is we can think about these relationships as being explicit to the logic, right? You can't use this kind of placement relationship without using the explicit relationship, right? Doing it explicitly, I suppose is the best way to say this. So this is why this is a beginning working session. This is the first time we've actually tried to sort of work through some of these specific things. But I think the list that I came away with is placement is the hardest one. Reuse is something we have to come up with some rules about, and why we'd use, on the reuse side of the types and stuff is a really fruitful place to look. Which I don't think we, I have the slides I have because they're sort of the ones we actually thought would be the hardest. Like replacing this mess is this reuse sort of stuff, or grouping, and then location.
So to further wrap this up, Craig, do you anticipate continuing this conversation?
Yes. Do I have an answer of how to do it right now? No. But what we'll start to do is make these discrete efforts. Like placement is a discrete effort. Reuse is a discrete effort. And that could be that we tag different groups of people to start to look at these things.
And I think data control and quality is a discrete effort, and project management and level of information as such is also a discrete important thing that we need to discuss in the bigger picture of what used to be called or will be called IDS and becomes IDS plus.
Yeah.
So let's go ahead and wrap this up, and we are breaking for lunch.
Thanks, everyone.
Thank you.
Bye.